Welcome back, children. So today we move into the most important topic of your class 12, that is calculus. In calculus, the first topic that we are going to deal with is continuity and differentiation. Now, we have just started something about continuity in class 11th. Before I start to tell you about what we have discussed in class 11, let us see what is meant by continuity, or what is the exact meaning of continuity. What does continuity means? Suppose that when you connect an electric circuit, there the flow of electrons is continuous, and that is why a bulb that is connected in the circuit glows, or the electric line outside. When do we say that there is an interruption in current or there is a power failure in our house? When that flow of electron to our house was interrupted, right? So this interruption shows you that there was something continuous there. That means there is continuous flow of electrons. Now similar to that, whenever you consider a function in its domain, for every value of this of the domain, you can have a continuous graph. If the graph is continuous in its domain, then we say that the function is continuous. Now let's take some examples. For you, let me take a small and a simple example, that is y is equal to x. When y is equal to x is a function that is defined in the set of real numbers. When x is equal to 0, what is the value of y? Y is also equal to 0. When x is equal to 1, what is the value of y? Y is also 1. X is equal to minus 1 gives y is equal to minus 1. X is equal to 2 gives y is equal to what? 2. X is equal to minus 2 gives y is equal to what? Minus 2. Now let me draw the graph to this function. Plotting the x-axis and the y-axis. This is 1, 2, 3. This is minus 1, minus 2 and minus 3. Here you have 1, 2 and 3. Now, when I draw the graph, x is equal to 1, y is equal to 1. X is equal to 2, y is equal to 2, x is equal to 3, y is equal to 3. X is equal to 0, y is equal to 0. X is equal to minus 1, y is equal to minus 1. X is equal to minus 2, y is equal to minus 2. X is equal to minus 3, you have y is equal to minus 3. When I draw the graph, or when I join these points, I can see that this is a continuous graph. This gives me a continuous graph. That means while I was drawing this graph, at any point did I take my hands off the graph? No. It was a continuous one. So I can say that this y is equal to x is a continuous function. Now let me take another function. Y is equal to x square. When x is equal to 0, what is the value of y? Y is equal to 0. When x is equal to plus or minus 1, y value gives you what? 1. That is, x is equal to 1, y is 1. X is equal to minus 1 also gives you y value as 1. X is equal to plus or minus 2, y value is what? 4. X is equal to plus or minus 3, y value is what? 3 square 9, and so on. Let's draw the graph to this function. So I have here x as 1, 2, 3. This is minus 1, minus 2 and minus 3. Here you have 1, 2 and 3 and so on. Right? Like this be 4 and somewhere around here is my 9, I suppose. Right? Okay. So now let me draw the graph to this. X is equal to 0. Y is equal to what? 0. X is equal to 1. Y is equal to what? 1. X is equal to minus 1. Y is equal to what? 1. X is equal to 2, y is equal to what? 4. X is equal to minus 2, y is equal to what? 4. X is equal to 3, y is equal to 9. X is equal to negative 3, y is again equal to 9. Now let me continue to draw this figure. What will I get? Somewhere here I am having, suppose. Okay. So when I draw the graph of this function, it goes like this. Fine. It goes like this. That means again when I draw this graph, this is also a continuous graph. It is not breaking at any point. Right? So whatever be the values of x I take, I get a continuous value for y in the graph. Now, let's consider the function y is equal to 1 by x. This is yet another function, right? Now, when x is equal to 1, what is the value? Y is 1 by 1. When x is equal to 2, y is equal to 1 by 2, which is 0.5. X is equal to 3, what will I get? Y is equal to 1 by 3, which is 0.333, etc. Right? Now x is equal to 0. Consider x is equal to 0. Can x take the value of x is equal to 0? No. So that means x cannot be equal to 0. Now what if x is equal to 0.1? X is equal to 0.1, I am taking a small value. What is that? Y is equal to 1 by 0.1, which is same as 10. Right? Now x is equal to, for all the negative values here, x is equal to minus 1, y is equal to minus 1, x is equal to negative 2, y is equal to negative 0.5, x is equal to negative 3, y is equal to negative 0.33. Suppose x is equal to negative 10, y is equal to negative, x is equal to negative 0.1, y is equal to what? 10. Right? Let me now draw this graph. I am drawing the graph for this function. I have 1, 2, 3 here. I have minus 1, minus 2, minus 3, minus 4. 4, 5, 6 positive values of y-axis. Somewhere around here I get it as 10. Okay. Now I have this side minus 1, minus 2, minus 3, etc. I have here minus 1, minus 2, minus 3, etc. And somewhere around here I am having minus 10. Okay, then what do I get? This is minus 10. Okay, now what do I get? X is equal to 1, y is equal to what? 1. This is positive. Y is equal to 1. X is equal to 2, y is equal to 0.5, somewhere around here. X is equal to 2.5, right? X is equal to 3, somewhere quite nearer. Now when x is equal to 0.1, that is closer to 0, that is giving me the value 10 here. So when I draw the graph for this values, that is the positive values, see I am drawing it here and then I get a value like this, right? This is how I get it in the first quadrant. Now see, let me mark the negative values. X is equal to minus 1, y is equal to negative 1, x is equal to 2, y is equal to negative, negative 0.5, negative 0.33, right? And when it is 0.1, it is minus 10. When I complete the graph, what do I get? This graph comes like this, right? It is coming closer to 10 and it is like this. Now, while I was drawing this graph or in this figure, you see that the point 0 is not touched or the graph is discontinuous. There is no continuity in this graph, right? The function 1 by x as such, when it is taken, there is no continuity in this graph, right? So this is the concept of continuity, or this is somewhat, I can say, I'm just coming to the geometrical conclusion about continuity, but this is all about the graph and continuity of the function. Looking at the graph, if you see that the function or the graph is a continuous one, there is no breakage in its in the points when it is taken and the values of the function. Here also there is no breakage here, but here you can see there is a breakage. Right? The function was defined for the set of real numbers, but still 0 cannot be taken, or the point 0 is not under discussion, or this graph as such when it is taken, you see there is a discontinuity. as the values of x approaches 0, there is a discontinuity at 0. Right? I hope the graph is clear to you. Now I shall discuss continuity in terms of limits. This is where I said that we had already discussed something about continuity. So in class 11, we had discussed about limits. Now, when do we say that the limit exists? Before we talk about limit exists, what is limit? I hope some of you will remember what was a limit. What was a limit, children? As the function, in a function, as the value of x tends to a particular value, what is the value of the function? That is what we had notated. Limit x tending to a particular value. Limit of x tending to a in f of x. What does this mean? In the function f of x, as the value of x tends to a, what is the value of the function? Right? This is what we had discussed. So, as the value tends to a, tending to a means what? This tending to a means this a is a point on the number line and the functional value tends to a. That can happen from the left side of a as well as from the right side of a. If the value of the function tends to a from the left side, we say that the limit, the left hand limit. How do we notate it? Limit x tends to a minus f of x. That is a minus meaning what? A minus. Right? That is a value that is lesser than a. Where do the value that is lesser than a lies to? To the left, right? So limit x tends to a minus f of x, meaning the function's value is approaching a from the left side of a. And the right hand limit, what will you write? Limit x tends to a plus f of x. What does this mean? As the value of the function f of x tends to a from the right hand side. That is what limit x tends to a plus f of x, right? And we had discussed already in 11, if these two values are the same, the left hand limit as well as the right hand limit are the same, we say that limit exists. What do we say? Limit exists. Limit exists for the function. So, limit x tends to a minus f of x, that is the left hand limit. We have already done this. Left hand limit is equal to the right hand limit. Then we say that the limit exists. Okay. Now, how does this deal in continuity? We shall see that in a graph. Okay. So, I hope this part is clear. Okay, so now let's move on to the graphical representation of limit. Where do we say that the function is continuous based on limits of the function? Okay. So, when is a function said to be continuous? The definition of continuity says that a function f is said to be continuous at x is equal to a if limit x tends to a f of x is equal to f of a. That means the value of the function at x is equal to a, that is f of a, must be equal to the value of the function f of x as x tends to a. As x tends to a. Okay, x is tending to a. Now, as we have already discussed, x tends to a means what? X value is tending to a from both sides of a. On the number line, this is a, this is x value in the function f of x is tending to a from both sides, that is from the left hand side as well as from the right hand side. So that implies to limit x tends to a minus f of x is equal to limit x tends to a plus f of x. A minus f of x is equal to limit x tends to a plus f of x is equal to f of a. That is value of the function at x is equal to a. Okay, now let's see the geometrical representation. Now let's see the geometrical representation. In the first figure, you see that the value of the function as limit x tends to a from the left hand side tends to this particular value. And the right hand side also tends to this particular value, right? As the value of x tends to a from the left as well as from the right, it is to the same value. But here you see a broken interval, right? Why? Because x is equal to a is not this value. At x is equal to a, that is f of x, f of a. In the function f of x, f of a is not equal to the limiting value from the right and the left. That is limit x tends to a plus f of x, that is from the right hand side, is equal to limit x tends to a minus of f of x. But it is not equal to what? F of a. At f of a, it is not equal to the limiting value. The limit value from the right hand side as well as from the left hand side is the same. That is, from both the sides it is coming to this point, but x is equal to a. At f of a, the function's value is not the same as the limit value. So here what can I say? The function is not continuous. Okay, this graph says that the given function is not continuous. Now coming to this side, the left hand limit means from here it comes, right? The left hand limit x tends to a minus f of x, right? Limit x tends to a minus f of x, that means it is somewhere over here. This is the value, right? Now, this value and limit x tends to a plus f of x. What is this value? It is somewhere over here. This is the y value, right? Are they the same? No, they are not the same. That means here the left hand limit is not equal to the right hand limit. So, does our function said to be continuous? No. Why it is not continuous? The left hand limit is not equal to the right hand limit. So, here also the function is not continuous. We say that it is discontinuous. When the function is not continuous, it is discontinuous. Okay. Now, see the third figure. Here, the limit of x is tending to a from the left hand side. What is happening? As the limit of the function tends to a, the functional value is tending to where? The functional value is tending to infinity. Do you see a joining of the function somewhere? No. As the value of x is tending to a, that is from the left hand side, as the value of x approaches a, the functional value is tending to infinity. What about the limit from the right hand side? That is a plus f of x. As the value of the function tends to a from the right hand side, you see the value of the function is also tending to infinity. In this case also we say that the limit doesn't exist. Okay, in all these three cases the function's limit doesn't exist. So, now coming to the fourth figure. Now, as the limit value of the function tends to a from the left hand side, right? It is approaching at this value, this point, right? It is approaching to this point from the left hand side, and from the right hand side, what can you say? A plus f of x. Where is it tending to? From the right also it is coming to this point. Which point? The point is same as f of a, right? When the value of the function tends to a from the left hand side, that is limit x tends to a minus f of x, is approaching this point here, right? A corresponding y value from the value of the function approaching from the right hand side also tends to this particular value, and this value is same as f of a. So all these are equal. Limit x tends to a minus f of x equals to limit x tends to a plus f of x is equal to f of a. Only in this case among all the four figures we say that the function is continuous. So I repeat, a function f is said to be continuous at x is equal to a if limit x tends to a, f of x is equal to f of a. Now limit x tends to f of x is meaning what? The value of the function is tending to a as the value of x tends to a. The function f of x tends to as the value f of x. In the function f of x, as the value of x tends to a, the functional value is tending to where? A common point. Right? That is same as our f of a. Am I clear? So this is continuity in the graph. Right? But showing the, suppose you are asked a question to find whether the function is continuous. Now, you draw the graph of the function and say it is continuous. That is not how we need to prove it to be continuous. We have certain steps. What is the step? The first thing what you have to say is the function's limit exists. The limit of the function exists. What does it say? Limit of the function exists meaning the left hand limit is equal to the right hand limit. Right? So left hand limit means what? Limit x tends to a minus f of x is equal to limit x tends to a plus f of x, which is equal to the value of the function at x is equal to a. That is f of a. You understand me? Now this is for the point, at a point. Now after which when we deal with the problems we will also discuss how to check for continuity in an interval also. Okay, so we'll start with the continuity to check the continuity at a point and then we will also check it for the interval. Okay, so this is the basic concept of continuity. Now let's discuss algebra of continuous function. That is, if f and g are two continuous functions, right? They are two continuous functions. Then f plus g is continuous. Right? That is the first algebra of the function. F plus g is continuous. F minus g is continuous. Right? Then you have f into g is continuous. And also f by g is also continuous. Right? This is the algebra of the continuous function. What does it say? If two functions are continuous, then their sum, their product, their difference as well as their division is also continuous.